Hello, everyone. My name is Jakub. I'm CTO of Intergalactic, and I'm building hydration. Today, I will talk about how we are using Polkadot SDK to build intent composing engine. I don't have too much time, so I will try to go over the whole process about how we do this. And then at the end, if you are interested in some parts of it, you can go talk to me upstairs. So, today we'll talk about how to build some more complex system using Polkadot SDK. We will talk about how to define the problem and find the best possible solution given some constraints, and then execute on this, pun intended. So, first, to build some solution, we need to define the problem space. So we need to know what we are building on. So hydration is a DeFi hub. It's home to Omnipool and other AMMs. It allows paying transaction fees in any asset. And it has swap-related automation like DCA. It has EVM compatibility. And next week, pending audits, we'll also have a money market. So, other than that, it is fairly standard Polkadot SDK chain. Bear in mind that we have a lot of plugins in it, but it's not very custom for now. So what is the problem? We first need to define some requirements that we have. So our requirements are to improve the price execution, add limit orders to our chain, add swap triggers, which are like post-swap triggers on success or fail. At the same time, we want to improve transaction throughput and add some cross-chain capabilities. So what are the constraints? We need to keep everything working because we are a blockchain. And it is not super easy task because we have more than 10 major features that we need to support in this big upgrade that is coming up. It also cannot take infinite amount to build, and it needs to be relatively cheap. And it needs to make least amount of possible breaking changes for the other developers that are using our chain. So let's analyze this problem. We need to check our existing code, Polkadot SDK and hydration node, to be familiar with it. In the past, we built order matching engine. It was August 2020 when we, on a hackathon, built engine where people could match opposing transactions together in single block and post transfers or swaps without slippage. The problem with this was everything was on chain, and it was actually a little bit slower than if we did normal transactions. So we scratched this. Next up, there came two protocols, which are pretty important. One of the first was CoSwap and Uniswap X. And these actually created a way to match transactions off chain and post the solution of this match transaction on chain and settle the transaction afterwards. Then there came Across, which will be very important. It's a cross-chain intent based protocol. And right now, very freshly, we have this ERC 7683, which is a cross-chain intent standard. And it's really amazing. It will allow us to do great things. I will talk about this later. So after we have defined all these problems, we have the specification. We'll go through it very quickly so that we all know how it works. Okay, I hope now you all know how it works. No, so let's dive into some small parts of this to show you like how we think about these problems and solve them. It's the most important ones. So how does this intent and solver-based system work? So we have an RPC, which collects the intents. Then we have a collator, which is a block builder on our chain. He puts the intents in the block. Then there is another actor, which is called solver. He is observing the block. He's taking all the intents from the previous block, composing a solution, and then posting it to the next block. This is like the initial design of this. In the future, we'll not need to have this block delay because the transactions will be posted straight to the solver, and he can then post the solution straight into the block that is supposed to be built. So what is an intent? Intent is a definition of action that user wants to do without specifying exactly how he wants to do it. Right now we have swap intents, but in the future we can have different types of intents, like borrowing or adding and removing liquidity. It has some properties, and these are the special ones that we have. It's like triggers, which you can call on success, on fail, or on partial execution. This will be triggered every time that the intent is solved. So, as we are trading, the intents are grouped into the solving groups. These are like swaps that can be solved together. Solver will take them, combine them in the package. He will construct instructions how to actually resolve these swaps. And then it's validated and posted to the block. And when it's valid, everything is just getting transferred back and forth without necessarily going to the pool. But unmatched transactions are going to a fallback, which is either fail or going straight to the one of the pools that we have, like Omnipool. So let's get a little bit codey. This is way how we submit the solution, and actually the interesting thing is how we compute the transaction size of this. It's actually calculating how many intents we have in the block, and then this is counting a transfer weight, which means that this is much cheaper operation than doing swap through some kind of AMM or other pool. And we can calculate that the worst possible scenario, if we have two matched intents, is 2 transfers and 1 swap in the pool. If you have more, then this scales much better because you have much cheaper transactions that are coming into the block, which are the transfers. So once you submit the solution, only the best one is picked. And we are currently tweaking the solving algorithm and the scoring on which we rate the best possible solutions. Current score is based on excess HDX, which is left over after all the matching. And we are using 2 papers to do this. One is optimal routing for constant function market makers. And the second one is outer approximation. And this is a part of the code, how it looks like. It's a bunch of math and matrices. So next up, we need to validate the solution. So basically, we take a score. If the score of the solution that is being posted is better than the last one, it's being kept. Otherwise, the transaction is thrown out. And after this, we validate all the intents and instructions. Once the best solution wins, this is what is done. Every intent instruction is getting executed and validated. If the solution is wrong, the solver will need to be slashed, because this is validated only after the fact that this is posted on chain. Otherwise, it would take the same amount of time on chain to validate the solution by posting it that it would take to execute it. So, as I said before, matched intents are settled by transferring, and unmatched part is settled against the pools. Okay. Now, as we saw, we need to completely reorder the block for this to work. And it looks something like this. First up, we had solution execution and liquidations for money market. And then everything else is basically in some order. Now, this is pretty custom. It's no longer standard Polkadot SDK stuff. Because normal order uses transaction priority and nonce of the user's transaction, and the weight to compute which transactions are going first and which transactions are going last. So for this to work, we need to allow for the users to have non-consecutive nonces inside of the block. Nonce is like an incrementing number which prevents repeating attack of the transaction. And we need to have custom priorities based off transaction type. So what about the cross-chain part? There is this standard, ERC 7683. It dictates exact structure how the intent should look like. It also standardizes the settlement interface, and it's currently supported by over 30 protocols and chains, and hopefully very soon hydration. And this means that it allows us to tap to existing solver networks and almost instant cross-chain execution for all the users of all of these protocols. So how does this work? The user posts intent on some chain that he wants to receive a token. He puts an escrow contract, and once the solver settles this on the destination chain, he needs to prove that he settled this intent, and then he gets reimbursed. This is usually done by the bridges. We already did hackathon on this with Hyperbridge guys, and it's looking very good. And yeah, that's mostly it. After this, we have this huge document, and it usually doesn't work like you invent in the first place. You need to start implementing it, and you realize that it doesn't work, and then you need to iterate on it and upgrade this document. So what do we get from this? Actually, we benchmarked it last week. It's not yet optimized or anything, but we will get minimum 5x increase of swap throughput. So that means 200 plus swaps per second after async backing. We can have 10,000 or more intents at the same time for the solver to be efficient. So this basically turns us into kind of order book. And we can have swaps without slippage, improved MAV protection, and as I said before, almost instant cross-chain execution. And also these triggers, what is special to us for automation. So that's about it for now. If you are interested about any part of this, I will be here around and come talk to me. Thank you. Stay hydrated, not liquidated.
Yeah. Jakub, thank you. Stay up here for a second. Let's see if anybody has any questions. We have a few minutes here. Does anybody have any questions for Jakub based on what you just heard right now? Watch out. Okay, you ready to catch? Bad throw.
We're here. Okay.
There you go. Should be good.
What will happen if no one will submit an solution?
There is a fallback solution that is being built by the block producers, and it will be posted always.
Great question. Thank you. Anybody else have a question while we have Jakub on the stage? Yeah, okay, nice.
I don't know too much about intents, but I see there's a signature in the intent structure. Does that mean users need to sign twice, once to initiate the operation and then the intent itself?
No, actually this is because you can also do off-chain submission in the future, and you need to sign the transaction and post it to the solver network. And it's already like a signed transaction. It only gets put on chain if the solver actually knows that it will be valid. So you need to have this ready to go.
Cool, understand.
Nice. Looks like we have some questions in the back. If you want to toss, we got this. Ooh.
Hello. Could you speak a little bit more about the incentives for block builders to include the most highly scored solutions?
Well, the default block builders do it by default. So they are incentivized from the standard collateral rewards. But we are thinking about how to improve this to prevent huge MEV, because the solvers can actually easily plug in transactions and maybe kick out of other ones. But in the way that the scoring system is designed, we try to prevent most of these problems, because we are targeting the best possible arbitrage and best possible prices for the users. And if we can achieve this, then there is really no issue with like a big front running or something like this, because they will need to put up the better prices, and in the end it will be better for the users.
Nice. Do we have a question? Yep. Nice. Ooh.
It's not intent-based. I heard there's a money market coming out. Do you have any release date for that?
Well, I said during the one of the slides alpha, if the audits go good, the next week is the launch.
Very nice.
Very good. Anybody else?